Welcome to video N2. We're going to solve a basic linear Diophantine equation. Here's the problem. Find all the integer solutions to 7x plus 13y equals 1. All right, so I'll just do this in a three-step fashion. Step 1. Check if this is even solvable. So to check if it's solvable, you find the greatest common divisor of 7 and 13. So the GCD of 7 and 13, which happens to be 1. And then 1 divides 1. So check it's solvable. Okay, so now I'll invest some time and effort. All right, just to save room, I'll erase that. Step 2, use the Euclidean algorithm to find the greatest common divisor of 7 and 13. Even though we already know it's 1, we've got to go through the process so we can reverse it and finish the problem. All right, so step 2, I'll say sorry about that. Use the Euclidean algorithm to find GCD of 7 and 13. Okay, so I start with the larger number. So 13 is going to be 1 times 7 plus 6. Okay, again, I'm putting the 7 and the 13 in there. Then, remember before, I underlined those. 7 equals 1 times 6 plus 1. Can I bring them over again? 6 equals 6 times 1 plus 0. So once I get a 0 there, I stop. And just to emphasize, the step above the 0 was the GCD. Okay. Step 3, I'll write it below here. Step 3, use Euclidean algorithm in reverse, and we're basically going to be solving for the right-hand side. Okay, and we're going to start at that GCD. So right here, I'll just go like such. I'm going to erase this right here. So starting at the GCD step, solve for the right-hand side. So 1 equals 7 minus 1 times 6. All I did is I got that GCD by itself. And then go the step above and again solve for the right-hand side. 6 equals 13 minus 1 times 7. So that's how I'm going to generate these two equations. Then I'm going to use substitution. So notice there's a 6 there. All of this is going into that step right there. I'll just use blue just to make it more colorful. So I'll write that below. So now I've got 1 equals 7 minus 1, all of this stuff. 13 minus 1 times 7. Okay, I'm running out of room, so I'll go over here. I'm going to distribute this 1. So I'm going to have 1 equals 7 minus 13 plus 1 times 7. Okay, I'm going to do one more step here. I'm going to say 1 times 7, just so you can see the like terms easier. So if I got a 1 times 7 plus a 1 times 7, I've really got a 2 times 7. I'm going to do one more step. Instead of saying minus 13, I'm going to say minus 1 times 13. And you may not realize this, but you're kind of done. Look at our original problem. I'll write that in green. Our original problem was 1 equals 7x plus 13y. Look what I've got going on. I've got the 1s, I've got the 7s, and I've got the 13s, which means that this is the x and this is the y. Be careful, I circled the negative sign. So I've got a specific solution of x naught equals 2 and y naught equals negative 1. The problem asks me to find all the integer solutions, so now I'm going to use that general form. So the general form is x equals x naught plus the other coefficient, if you will, times some multiple n, and y equals y naught, negative 1, minus the other coefficient, if you will, where n is any integer. And that is the general solution to this linear Diophantine equation. One more thing, just since it's the first time, let me generate 3 specific solutions. I've already got one, but just to show you, I could let n equal negative 1, in which case x would be 2 plus 13 times negative 1, which would be 2 minus 13, which would be negative 11. Y would be negative 1 minus 7 times negative 1, negative 1 plus 7, which would be 6. So I'll just write that as an ordered pair. That would be negative 11 by 6. If n equals 0, I'll just show you. X equals 2 plus 13 times 0. Y equals negative 1 minus 7 times 0. That's going to be 2. That's going to be negative 1, hence my nods. I'll write that as an ordered pair. 2 comma negative 1, and I'll circle them. And then finally, if n equals 1, and you can let n be any integer, I'm just going through these 3. So if n equals 1, x would be 2 plus 13 times 1, y would be negative 1 minus 7 times 1, and that's going to be 2 plus 13, that's going to be 15, negative 1 minus 7, that's going to be negative 8, so that's going to be 15 by negative 8. So once again, here are 3 specific integer solutions, and here is the general form. And there you have it, how to solve a basic linear Diophantine equation, and we'll have some more examples coming up.